morning from my time zone to everybody. Welcome to my session where I'd like to speak to you about reuse of PDF content and specifically about my experiences with interoperability between PDF and HTML. My name is Toda. I'm from Normex. We are specializing in PDF, helping our partners to build solutions, libraries, or products. I consider myself as a developer who strongly believes in open standards, and I'm actively participating in the standard development through PDF Association or ISO. But today I'll be speaking to you as a chair of the Deriving HTML from PDF Technical Working Group at PDF Association, where this work was actually born. Let me briefly tell you about something about the history of PDF and the path from the very first idea of capturing representation of a paper in digital form. That was back in 1993 when PDF 1.0 appeared. Basically, back then we only needed to accurately represent what you see on a paper and then show it on a screen or reprint it to the paper. We needed basic structures or format, file format that could be used independently on implementation and or operating system, etc. And we used an approach to define PDF as a container for other technologies, image formats, font programs, color spaces, and so on. That was a time when we started to use word rendering as a synonym for a program that interprets the document on a specific device. Very quickly, it was in PDF 1.2, we realized that we need to record also semantic of the document. That's when marked content was introduced, and you simply add markups to certain content elements to get a meaning of those objects. Version 1.4 was released in 2001 with completely new entity on top of existing marking content approach. It was called structure tree, and it is the main entity for accessing the content elements through order defined by tags instead of usual rendering order. The whole concept is called tagged PDF and quickly started to be used as a main entry point for consuming PDF by assistive technologies. Basically, we addressed the accessibility needs by introducing it. And it took another 11 years to release PDF UA, or in 2012, if I'm correct, as a universal file format for accessibility. And now you have to understand that every step in our evolution was designed with backward compatibility in mind. That means every new version is read by old processors as well. PDF is now one of the most important assets on the web, but isn't really an integral part of the web. An HTML developer cannot control the user experience when showing PDF as a part of standard web page. PDF viewer is basically a container inside of a web page with very little interaction between the rest of the page and PDF. There are problems with navigation, interactivity. PDFs can't be responsive when resizing the web page or using it on a mobile. And in 2019, we believed we came up with a solution, the Deriving HTML from PDF algorithm that produces HTML from a tagged PDF. We showed how certain structures in PDF are used in the process, how author can embed important data that affect the output HTML, and again, with two very important points in mind. Author of PDF controls the output, not the processor, and such PDFs are backward compatible. As I said, the concept is to convert PDF structures, tags, attributes, associated files. We are considering actions, class maps, namespaces, role maps in very deterministic way. We are also considering differences in PDF and HTML languages. In this image, we show I show Annex L from PDF specification that defines allowed parent-child relationships in PDF with problematic points marked in orange or red after deriving into HTML. That's all been thought through, so author and developer can be absolutely sure that the output HTML is always a valid one. This is our resource page on GitHub, where you can check our implementation of the algorithm application that allows you to see PDF and derived HTML side by side, and a lot of sample files. Because as you can imagine, the PDF files that are authored for the derivation are those we can see the best results on. We lay the foundation, but it is really up to the way you construct the PDF. And I forgot to mention that whoever is interested in the work is welcome to join us in our effort through GitHub or directly joining the TWG PDF Association, of course. So after implementing and starting to integrate the algorithm into standard workflows, we quickly realized that we don't have good tagged PDF files. And I'm not talking about those prepared for derivation, just standard tagged PDFs. On the side of creators, they barely produce tagged PDFs. They don't produce PDF 2.0, in which the most important improvements have been made in the area of tagging. Authoring tool might not even have the information needed for good tagging. That's surprising. Creators insert inappropriate attributes. They break the rule of NXL. But there are no validators to check the well-tagged PDFs. And if there are only checkpoints for passing accessibility requirements. And on the side of PDF editors, remediation is a manual process and minimal effort is usually used to produce accessible PDFs. There are no tools to fully control the process of tagging. And if they are cumbersome to use. And very important reason, it is very expensive and time-consuming to make good tagged PDF files. We also saw a lot of files where bad tagging is still okay for accessibility, but very bad for reuse purposes. And we realized that the industry sees tagged PDF as a accessible PDF, and therefore the difference isn't defined or quite obvious, like what is the difference between tagged and accessible PDF. You have to understand that there is a difference in consuming of semantic and consuming of the content. Accessibility requires semantic appropriateness. So table structure element, for example, cannot be used in a situation where we only want to lay out content in a nice way. It has to represent the tabular data. And I know this is a best practice in HTML too, but HTML developers are not that strict. There is obvious difference between page media and uninterrupted content flow defined by tagged structure. So the conversion would lose the information about page breaks, for example. There is lack of direction in tagged PDF documentation, lack of validation means, basically. We saw a lot of technical obstacles as well. How would you properly represent table of content that has a meaning in large documents as a part of the content, but navigation in HTML are more likely defined differently. Bookmarks are better structure for that, but you can't really artifact TOC in PDF just to please the derivation algorithm. Invisible content is not derived nor used in accessibility. But what if we have invisible form field that is used for calculations? There are structures that are not captured in a structure tree, like outlines, page labels, metadata, validation information from digital signature, etc. we faced a problem of inability to treat headers and footers as real content, for example. That might be different between accessibility needs and reuse needs. Like what to do with important information that is in a header, how to define dynamic information in a footer, what with a link in a header or footer. Interestingly, PDF UA requires that every link has to be tagged, but header and footer are considered as artifacts. So what if different attribute owners contradict? What to do with links across pages? In PDF, there might be 2 links on each page one. And another big chapter is the derivation of acroform in JavaScript. And of course, annotations. So at the beginning, we had this picture in mind. Something called well-tagged PDF would be derived into HTML. And we had just very vague idea about what is well-tagged. What does it mean? We used the term as a prepared for derivation, or better to say, authored for derivation. But the world is more complicated, and we usually started with PDF that needed to be turned into a well-tagged, which is a complicated task by itself. And there exists plenty of web pages that derived HTML needs to be integrated into. Of course, to have the picture complete, we have to say that there exists an easy way from HTML to PDF through printing, obviously. Luckily, the landscape is changing. Sure, PDF companies offered HTML to tag PDFs before, but in the last 2 years, we saw dramatic change. The quality of tagged PDFs is a lot better. And to be fair, it's not just about HTML converters. We may talk about Office formats too. Nowadays, browsers can produce even tagged PDFs and PDF UA files directly, which is great. And that's a good sign, because conversion to well-tagged PDF is easier from already tagged PDF, right? Although we already lost some information on the way, of course. More conversions in a pipe, more losses. So in our research work, we tried to target the obvious tasks. Can we directly produce well-tagged PDFs from HTML? If we close the cycle, HTML to PDF and then back to HTML, what would be our loss? What if we started the cycle from PDF, so PDF to HTML and then back to PDF? Can we maintain all aspects of the HTML in PDF? Things like, if I had accessible HTML, would I receive PDF that is equally accessible? How would some operation impact the well-taggedness of PDF, like editing or annotating and stuff like that? Can we use HTML as an engine, or let's say definition language, to produce well-tagged PDFs, or a big one? Can we build an ultimate PDF tool that is HTML based on derived HTML instead of being based on PDF? For me as a developer, one sample, one implementation is obviously worth more than great standard or document describing the algorithm. That's why I wanted a hands-down experience. With the help from Foxit, I was able to explore some of those ideas, knowing how PDF has to look like to be able to derive it into HTML. We started small research project with direct HTML to well-tagged PDF conversion. Foxit obviously does have HTML to PDF, or better to say HTML to tagged PDF conversion with clear business aim. User need accessible documents. They gave us access to the sources and all necessary help and resources to test whatever we needed. And the idea in back of our minds is to reuse as much information as possible in a way that wouldn't compromise the business goal of the application, which wasn't really possible, but you'll see. Okay, to restate the obvious, HTML to PDF isn't one-to-one conversion. There are some tags that do have a twin in PDF, like div or span. There might be some that can't be expressed in PDF, bold, italic, for example. Interestingly, we don't have in PDF any way to convey this information about bold and italic in PDF. There is no layout attribute. There is no way to include such information in other attribute owners like CSS or HTML. The information can be found in font, of course, but that's not exactly the same. We are mixing semantic and visual appearance. The only solution is to define our own role map, where new structure element would be introduced, role mapped to span, but then the derivation algorithm would need to be aware of the role mapping. So some adjustment in the universal derivation algorithm is needed. Some structures are similar, almost the same, I would say. Just the mechanics differ. Let's mention lists as an example. Distinction between ordered and unordered list is done through list numbering attribute in PDF, quite the opposite in HTML. An attribute is used to define labels, while in PDF we use combination of attribute and LBL structure element. This requires very precise definition. And what if the content of LBL in PDF isn't aligned with the list numbering attribute? And in the opposite direction, if we had very special bullet in PDF LBL, we would need to define some non-standard styling in HTML, stuff like that. And some tags in HTML are simply not expressed in PDF at all, like time, for example. So we had to ask a question: do we really want to carry or to go back to time when deriving into HTML from PDF after having an experience with unchanging content in PDF? So it's a tough call, and we haven't yet reached the more sophisticated problems like interactive elements, converting JavaScript, and complex CSS styles, although there are some strategies for that. So let's see what is possible. When converting to PDF, you want to convert as many layout attributes as possible. Some of them come from rendering engine, I mean the HTML rendering engine. Some of them are coming from HTML attributes. Structure element has an array of attributes, but I'd strongly recommend to have all layout attributes in a single dictionary. We saw some implementations that generate multiple layout attributes on dictionaries, layout attribute on the dictionaries on one structure element in a hope that processors would merge them properly. There is a problem with well, basically, I couldn't find any requirement about this in PDF, whether this is allowed or not. PDF 2.0 allows adding HTML and CSS attributes the same way as with layout or table attributes. One can even use class map as shown on a screenshot. And each class, as you can see here, each class name defines set of CSS attributes that are converted to CSS styles and referenced by the name from HTML tag. This seems like a straightforward conversion of styles to PDF, but you have to keep in mind that just embedding CSS and HTML doesn't help you with achieving accessibility. And I forget to mention that HTML attributes can also be included in the attributes array as well, and are subject of derivation too. So I wanted to say that layout attributes are still important to take across, and attributes like table or list are necessary to have. For example, call span and row span, they are must in PDF UA, so you can't really carry them as HTML attributes only. For a developer, is a lot easier way to embed styles with the use of associated files. One way of doing it is through URL binding, shown on a screenshot. The other way is to use embed files, where the whole CSS style sheet is inside of the PDF, and during the derivation is saved into separate CSS file next to HTML. The problem was how to properly associate the name of specific style from associated file to a specific structure element. If the style was in attributes, we would use the C entry on a structure element class that would contain the name of the style. But now we can't really use C entry because there is no such entry in class map. The only way we found was to add HTML add class with proper string, HTML attribute class with proper string. We also implemented a method of conveying the semantic through the use of HTML namespace. To refresh our memories, PDF 2.0 defines namespace mechanism that allows the use of various tag sets. Simple use case is to use mathematical formula in a document. It is a perfectly valid and great from the reuse point of view to use formula structure element with kits in the MathML namespace. So processor can directly take that MathML content and use it in other environments. So PDF 2.0 introduces HTML namespace as a first-class citizen in PDF, and it is valid to have tag PDF, as you can see on screenshot. You basically convert HTML tags into HTML-looking structure element. You assign namespace, and one would think that this is exactly what we need. And yes, it's pretty easy, but not without problems. The big one is, of course, that nobody is supporting it. It is not entirely clear how to meet accessibility requirements. And so basically you need to provide role map to standard structure namespace. In this case, body would be role mapped to document, A would be role mapped to link, and so on. But as you see on the sample here, list in PDF requires L-body, which doesn't exist in HTML. If we didn't artificially include L-body in the structure tree here, there will be no element that we could role map to L-body. So it's almost impossible to do the role mapping of purely HTML-based namespace document to a standard namespace. So in a nutshell, all things we implemented and tried: converting things to layout attributes, adding CSS and HTML attributes. I have to say that we didn't experience any problems with combining these attributes. I would say that golden rule is include as much as you can. URL bindings. That's a tricky one, especially when you see it through PDF lenses. You have to understand that when converting HTML to PDF, you see something on the screen. After conversion, you obviously capture the styling in PDF content, and if you derive to HTML back, the URL target might be different, so you might get a different result. But there might be use cases where this is expected, and a good one, right? Then we tried embedded files. I didn't mention that we can attach also JavaScript, and we have also samples of that as well. And we did the HTML namespaces. And honestly, I believe that we would need some more thoughts about namespaces, some real-world implementations to see how to use namespaces, combinational namespaces in single document. Forms, for the lack of time, I didn't mention that we also implemented the derivation of icon forms to HTML, but haven't fully done the job of converting HTML forms into icon forms. More about forms on next slide. But I have to mention that converters usually don't convert the interactivity. They are only flattening the visual appearance and use print field attributes to mark this as a non-interactive field. To sum up what we learned, there is no point in seeing PDF and HTML as a replacement of one or the other. PDF are in nature large documents with tens of pages, while HTML pages can't really be long. They complement each other, and we should make sure we can use advantages of one in the other world, hence the derivation algorithm that isn't meant to be a way of round-tripping between HTML and PDF. We learned that there are a lot of invalid HTMLs as well. Well, we knew that, but it was surprising to see how many HTML files are technically invalid. Well, invalid. That word isn't really used in HTML world. Whatever browsers consume is valid. In PDF world, we have many renderers, many libraries, processors, and so on. HTML world is becoming more centric around very few important engines and components, like Chromium with Skia, Blink, and others. The incompatibility tag set, that's not a surprise. I think that's a good one, something we may want to look at, but won't really need to. We don't really need to solve it by nature. Those are different languages. Incompatible tag sets are expected. HTMLs could be very complex. Honestly, I was surprised how much developers include big and complex frameworks to achieve simple tasks, which makes conversions problematic. Forms, I mentioned, we did some work around forms, but I believe we would need to change the way we see forms in PDF. HTML world is always online, while PDF world is always offline. That is by definition, and we might want to see this as an advantage of both, and not to try to unify approaches here. And I forgot to mention media queries. We tried some techniques that would allow us embedded information in PDF in a way that would capture what is achieved with media queries in HTML, or better to say, multiple targets. Imagine something like one PDF with several structured trees, each for a specific target. I think it is obvious that the work on derivation generates a lot of questions, pointed to a lot of gaps, and that we are not finished yet. It is not just a matter of implementations or tooling, and at PDF Association we realized how incomplete the picture still is. I listed here work items that will help, or the results will help to move forward with the whole idea of interoperability, content reuse, and simply having PDF better incorporated in the web, while still maintaining the advantages we have, like archiving, printing, and stuff like that. And I have to say that the work on those topics started or was initiated based on the results we gathered during the developing the derivation algorithm and implementing it. And it's not just me. Other big companies are releasing products and features that use the same approach. So back to those work items. There is a WellTag PDF technical working group that works on a standard that would define what is and how WellTag document would look like. What are differences between PDF UA and WellTag, how to best construct reusable PDFs. Forms technical working group, we are defining replacement for hyperforms that would be more interoperable and more secure. An Excel update. An Excel defines the inclusion rules for all structure elements. It is a normative list of allowed parent-child relationships between tags. We found some problems that were addressed, and specifically, we are looking at inclusion rules when mixing standard structure namespaces for 1.7 and 2.0. There was a lot of ambiguities in combining 1.7 and 2.0 namespaces in single document, which made it harder to mix. And it is a healthy thing to mix those tag sets in various scenarios. And of course, the list of tasks around tagging wouldn't be completed without PDF UA2, which is, by the way, the last missing standard based on 2.0, PDF 2.0, that wasn't released yet. As you can see, the development and landscape around tagging is very, very live and agile. I would say almost non-PDF agile. And this all should be a warning for those developers and companies who are reluctant to accept that our world is changing dramatically. Basically, those who don't produce tagged PDFs by default, those who still print to PDF or use virtual printer to generate PDFs, those who use functions on PDFs that can damage tagging, those who don't use tags when reusing content, export, copy out, and so on, those will simply be in trouble very soon. Once again, if you are interested in our work, please check our implementation, samples, comments, get in touch on the links above. PDF Association members join technical working groups, and non-members, of course, join PDF Association. And want to thank you all for coming and showing interest. And I think it's a good time to answer some questions, if there are any.
Thanks, Roman. So yes, as Roman says, we're now going to begin the question and answer portion of this webinar. If you do have any questions, you can feel free to submit them through the questions pane in your attendee control panel. So Roman, there is one question that's certainly raised for me in listening to your presentation. So as you mentioned, the world of HTML processors and renderers is centralizing. Now, how does that factor? That's one of the big changes out there that's happening over the past 10 years. Well, maybe even is taking that long. How does that change influence the approach to the derivation problem? Do you think it leads to a world where because the big implementations are slow, it becomes slower at changing the way they do things, people are going to start writing lots of hacks to make it happen? Or is it actually going to make things a lot easier because there'll be fewer targets for conversion processors to have to consider? Or what's your thought?
Well, after, as I mentioned, a lot of PDF companies already did have the PDF to HTML converter, or PDF to HTML to tagged, HTML to PDF converters, or HTML to tagged PDF converters. But since the HTML world is centralized, applications or browsers basically share the same core, it is easier for them to share also and use the core implementation of Skia, for example, or Chromium or Blink, and adjust these to produce better tagged PDF files. So what we see is that as soon as the work on the engine in Chromium started to produce the tagged PDF files, it was very quick when from the beginning till this point, when we can see that Chrome is able to produce nicely tagged PDF files out of HTML. And since this all is open source, it's a lot easier for companies and developers to reuse the code and to produce and reuse the same knowledge that that developers make or the effort developers make in these engines, and build their applications and solutions based on top of that. Of course, the good thing is, since we will be using only one engine, we will see unified PDF files which are easier to handle. Mm-hmm. So I think in the long run, it's a good thing for the community, For the companies, that might be a little more problematic. They have to adjust to the changing environment, so to speak.